All right, guys, let's get back to it. So I'm going to make a big assumption that you all know how to plot points. Nope. Even with that, I'm still going to assume it's true. So if you wanted to plot the point, for example, 2, -1, and -4, 3. Which quadrant is 2, -1 in?
Bottom right.
Quadrant 1, 2, right.
Yeah, 1, 2, 3, 4. Right, just to be real dicks, we decided to go counterclockwise. So 1, 2, 3, 4. So it's quadrant 4. Because 2, -1 would be
Over 2 down.
over 2, down 1. Good. So it's always x, y, right? It's the x-axis. Here's the y-axis. This is the z-axis coming out here. But we're not going to do that this semester.
Is that calculus?
3D. No, not even that. It's pre-calc.
And then 2.
Yeah. It's actually, we're going to do a little bit of that this semester in here. We are going to have a third, not yet. Where's -4, 3?
Quadrant 2. Quadrant 2.
I like it. So how do I get there?
Back 4.
Back 4?
Up 3.
Up 3. All right, so there's -4, 3, positive 3, Jeff. And there is 2, -1. Can somebody help me out? How do I figure out the slope?
It's rise over run. So.
Not even there yet. I appreciate that though. It's coming soon. It's coming soon. I didn't mean to be evil. So the rise here, if I start here, how much do I go up? Then I go 1, 2, 3, 4. So it's 4 up. And then back 1, 2, 3, 4, 5, 6. Right? You guys with me? Okay. And it's nice. Slope in math is the same as it is in real life. So if I'm climbing a mountain that's got not too bad of a slope, that's not bad. If I'm climbing a mountain like that, it's a little more interesting. Of course, if I got to climb a mountain like that, it's even more interesting. But slope, like you guys said, is rise over run. So I rose 4 and I went back 6. So this slope would be -2/3. Anytime the slope reduces, that means there's a nice point in the middle. So if I went down 2, 1, 2, over 3, 1, 2, 3, that point's on the line. You with me? Does it make sense?
Yes.
So any multiple of any fraction that this is related to, that's another way to take a bigger step, or if I reduce it, a smaller step, and I still get back to the same line. So I always thought about like the line is my path through the jungle or whatever, and if I get off the path, the slope tells me how to get back on the path.
If you didn't reduce it, would it work out? Would it be on the line or no?
How do you mean?
4 over negative.
Yeah, this is 4, -6. Now if I go up 2, back 3, that's still on the line.
Okay.
Up 2, back 3.
Yeah, okay.
All right, cool. Okay, pretty good. That's by itself. Now, if I bring in the algebra of this 4 up was really how much what changed. If I go up and down, which variable is changing?
The Y.
The y. So the top here was the change in y. You guys ever seen that variable, that symbol? That's the Greek letter delta. And it stands for change in. I'm not going to use it that much, but just to put it up there. All right. So if I see delta y, that's change in y over the change in x. Now somewhere you see this all the time, especially if you go down towards Mission Hills and stuff where things get a little steep. I mean that one hill when you're going towards the airport where the stop sign is there only just so people don't go flying over it. You know what I'm talking about? You guys get that at all? All right. So go towards the airport on Laurel. You got this thing, stop signs there, and it's not like a yay. If you're driving in Colorado or anywhere there's mountains, you see on the side of the road, besides the runaway truck ramp signs, which freaked me out the first time I saw it, because I grew up in Florida, where the ground goes this way. You also see the grade, and you see that around here too. So if it said 7% grade.
That means you can speed right there.
Huh?
So that means you can speed.
Yeah. It means, for some people it means they're going to speed no matter what. So 7% grade. 7% of course is, what is a fraction?
7 over 100.
7 over 100. So that means for every 7 feet forward, for every 100 feet forward, because this is run, every 100 feet forward, I would go up or down, depending on which way I'm going up the hill, 7 foot. So if I'm going up, for every 100 feet over, I go up 7. Some of you guys might realize 7% grade is a decent grade. I think the most I've ever seen is like 10% grade, and that was crazy. Somebody else told me it was more than that. Like that's really insane. It doesn't sound like it would be a lot. 7 foot for every 100. You guys kind of with me? Mm-hmm. That's that idea of the 7% grade is exactly this idea of slope. That's exactly what it is. Kick ass. Right? So that's nice graphically. If I give you the graph, you can figure it out. Now I want to figure out what's the equation for this. And of course, to figure out the change in y, if I call this one x1, y1, this one x2, y2, because that's the first point and that's the second point.
The length isn't that supposed to be?
Not quite there yet. This is just slope by itself. How much does the y change? y2 minus y1. Does that sound familiar? Mm-hmm. Better. The only reason that 2 and the 1 are there is so you don't go the wrong way. If I go this minus this, I must then go this minus this. So if I did 3 minus negative 1 on top, I must do negative 4 minus 2 on the bottom. So that would be 4 over negative 6, which is my negative 2/3. Whereas otherwise, if I went negative 1 minus 3 on the top, I better do 2 minus negative 4 on the bottom. You guys with me? Otherwise, your slope is going to be in the wrong direction. And the guy's going to come around the corner expecting that and getting this. Ooh, shit. So then this would be 2 minus negative 4. Still negative 4 over 6, still negative 2/3. That's the only reason that 2 and the 1 is down there. Just so you go the same direction. Yeah, the time this part, yes.
I don't know how to do it that way, but I learned a different way. But I don't know if it always works.
What's the way?
If you put one point under the other one, and then change the sign. Like you put 2, negative 1, then negative 4 over 3 on the bottom. But no, without the fraction. Just without the fraction.
Wait, so you just put 2, negative 1, 4, negative 3. Or negative 4, 3, yeah?
And then you subtract 2 minus 4 is negative 2. But up and down.
Yeah, okay.
And
Sure.
negative 1. Yeah.
So you're doing that just in a strange,
Yeah.
just to be blunt.
I
I don't know why somebody taught you that way, but if you keep it straight where things go, you're doing the same thing we are, just sideways.
The AP method, I never remembered either.
The what now?
The AP method or the one that...
Surefire.
Oh, yeah, sure, of course. There's going to be stuff I show you that you don't know. If you have another method to do something, as long as it's legal. All right, some of you guys get your homework back. I pointed out to you which methods were not legal. All right, so let me know if that doesn't make sense. But yeah, that's fine. It sounds like that's the same thing we're doing, just sideways. All right, so this here, slope, of course, is given the letter M because it's a French word or something. Can't remember now what the French word was. It's not marché, it's long. But it doesn't really matter. All right. So it was Mr. M that came up with slope.
What section are you teaching right now?
9-3. So slope is y2 minus y1 over x2 minus x1. And the really cool thing is it's the change in y's over the change in x's, and the change in y's rhymes with rise. Kick ass. So it's rise over y. Sweet. Now, how does this tie into equations? Like the one he brought up earlier. If I have let's say this equation here. Can you guys help me out and give me some points? 0, 3. I like it. So when x is 0, y is 3.
1, 5, 1.
When x is 1, y is 5. When x is 2, y is... that's enough. Get the idea. So when x changes by 1, y changes by 2. So that's exactly slope, isn't it? And why does y change by 2 every time x changes by 1? Because of that number 2 right there. Whatever x does, it's doubled for y. This 3 here just tells me where I start. And then if I go over 1, I go up 2 on the y. Over 1, up 2 on the y. You with me? So I call it the amplifier. That's why in the equation, m goes there. Because whatever number that is the slope. It's how much y is changing relative to x. That's slope. How we know so far? Is that? Okay, again, poker faces are on. I got you. And of course, this guy is obviously going to be the y-intercept, because when x is 0, I'm on the y-axis, I'm at 3. Whatever number's there, when I make that part 0, y is that. So that's why that's the y-intercept. So this equation, yes?
I'm sorry, I'm just trying I know that's the y equals mx plus b, but the m, that's the slope, right? So the 2 is the slope.
2 is the slope, exactly.
Okay, so,
B is the y-intercept, because when I make x 0, I get it. And that's how I get the y-intercept. Let x be 0. M is the slope because it's how much y changes relative to x. It's the multiplier of x. Whatever x does, y will change by m times that. That's exactly slope, right? Slope is all about if x does something, what does y do? That's why it makes sense that that's the slope. Okay, cool. So one way to graph an equation is to collect points. But we are past that now, right? You are past that the minute you came in this class. Now we're going to definitely, and you should have done this before too, how do you graph this equation using just the slope and the y-intercept? So remind me, slope here is 2 over 1, I like it. Y-intercept is 0, 3.
so you just plot 3 and then you rise over run with this.
Yeah, so plot 3. Okay, I'm gonna plot 3.
Up 2 over 1.
And then the slope says go up 2 over 1.
Up 2 over
Now
1.
here's the cool thing about the slope. I want you to realize this. This is something people don't quite get. Slope is all about, if I start on the line, it'll get me back to the line. But I should be able to go in reverse also, right? And of course, mathematically, 2 over 1 is the same thing as negative 2 over negative 1. So the math would say, ooh, you put a negative on the top. But the graph would say, oh shit, now I'm going the other way. So it actually ends up meaning something different visually. It's kind of neat. So negative 2 over negative 1 would be down 2, back 1. Still same line. All right. All right. If you miss a point, just make it bigger. So if you are anywhere near as messy as I am, sloppy with stuff and can't draw worth shit, get some freaking graph paper. All right. Hopefully I have a few students who would even be anal retentive enough to use some colored pencils. That would be awesome. If I was a student, I would never do that, but I love that. I would hate me as a student. I would throw me out of my class. Okay. So how are we doing so far? I mean, that should be review. Anytime we're in 9, it's review. Yes.
So when we get to doing the quizzes and the tests and stuff, are you going to give us graph paper?
Yeah, I'll have little graph things on the test.
I just curious.
Yeah. So a couple of special cases. What do we know about this equation, this line here? If I had to graph this in 2 dimensions. So if I graphed it in 1 dimension, done. All right. Yeah, if I'm graphing it in 2 dimensions, x has to be 2. What does y have to do?
0.
No.
It goes up at this.
What does y have to do? Does this equation say anything about y has to do anything? No, y can do whatever the hell it wants to. Y can be everything it wants to be. X must be 2. x, if I change x, which way would I go?
Let's just go, yeah.
So if I'm not allowed to change x, I can only go,
Up and
there
down.
we go. So it would be a vertical line, beautiful, right? So this would be vertical line at 2. Because then what's y doing? Anything it wants to. Y is 1, y is -7, y is everything. X stuck at 2. Oh, shit. So what do you think about y equals -1?
X can do whatever it wants.
Then x can do whatever it wants, so it's going to go this way. It's going to be horizontal. Because y is stuck somewhere, so I can't go up and down. I can only go left and right. Cool.
Yeah.
Sweet. So be really careful. What's the slope for this one?
0.
Beautiful. And you can see it. This is y equals 0x minus 1, right? Because there are 0 x's here. This is 0 slope, which makes sense. That would be flat. 0 slope. Awesome. My first car could actually do that. Admit it, it's a little bit enough. This is not too far off from the truth. This slope,
Undefined.
good. This is either, you can either say undefined slope, or you even say infinite slope. I'll take either way. Infinite kind of even makes sense here because you just keep going infinity straight up, right? And if you take a couple points, somebody help me out. What point is this? 2, 1. What point is this? 2, -1. Incredible. Now, how do you find the slope between those two?
Y squared minus
Yeah, it'd be 1 minus -1 over 2 minus 2.
0.
Like m equals 2 over 0, which is, all right, that's why it's undefined slope. Because it is. All right. How we do so far? So I know I just said that this is all review, but I don't want to make you feel bad if you have a question or something that's bugging you or you didn't know something, whatever. Slow me down. How do you, I said this one earlier, but if I give you an equation like this,
Try to do less and
no, how do you find the intercepts?
You subtract 2x.
Yeah. X-intercept, what will you do?
Set y.
Yeah, good. Set y equal to 0, because if I have y equals 0, that means I haven't gone up or down any, so I have to be on the x-axis. That makes sense. That's why it's got to be the x-intercept. So if you set y to 0, you get
14.
14. Now I'm going to purposefully do something a little weird. Y-intercept I would set. Isn't that crazy? So just to let you know, the last math course I took, we had equations that had like 17 variables in them. But if I wanted to find the W-intercept, I made all the other letters 0. So this idea of if I want to find this intercept, I make all the other letters 0. Well, for us, we only have 2 freaking letters. So if I want to find the x-intercept, I make the other one 0, y 0, so forth. You guys with me? But that idea goes forever. For some reason, people forget this. It's a very simple idea. If I set x equal to 0, I get
4.
yeah, y equals 4. Now, the big mistake I see is somebody comes along 2, 4, 6, 8, 10, 12, 14. And they do this. Yay! Where'd that come from? First off, it's tilted for you guys, but too bad. So it's trying to be 14 and 4. They put a point right there. 1 point, and they're like, how could I graph that? And then they just draw a line through it, just hope. What did they do wrong?
The Y-intercept.
How many points have we figured out? 2.
Yeah.
So what is this point really?
14.
X is 14 when y is 0.
0, 4.
X is 0 makes y 4. There you go. And then you have 2 points. Right? So there is a purpose for teachers always making you write the points so you don't make a mistake like that. They're 2 separate points. Cool? Okay, good. Of course, I think somebody else is trying to tell me to solve, to figure out the slope in the y-intercept, what would you do here? Solve for y, exactly. Force it into mx plus b form. And this happens a lot in mathematics, believe it or not. Just by rewriting this, just by solving for something, everything else falls into place. So sometimes it sort of feels like magic. That just because a 5 ended up in the right place, it's the slope. But it's really cool. That's how it happens. It happens with circles and ellipses and hyperbolas and all this kind of stuff. Whoa, we just fell out. Okay. Blah, 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 blah. Oh, so we have this equation. And what's the other one? Somebody know? And really quick, if you solve for m, how would you solve this for m? No. How do you solve for m? How do you get rid of this? You just divide by it. So you get m equals y minus y1 over x. What does it look like? Slope formula where I'm saying the other point can be any point you want to. If I take any 2 points on a line, the slope will always have to be the same number, right? So it doesn't have to be this one and this second one. It can be this one and any other freaking point you want. So that's the slope formula where I'm saying here's a point, you pick any other point you want to, and it's the slope. And then I just multiply the x's up, and all of a sudden it's a whole freaking new equation. How are we doing so far? Is that familiar, these two equations? Definitely that one is. Depending on your teacher, you know that one better or not at all. Depends. Okay. How can I tell if two lines are parallel?
Yeah, the same slope.
Good. The slope would have to be the same, right? The minute the slope's a little bit different, it's going to run into the other one somewhere. You with me? So how would I tell if they are exactly perpendicular? And what does perpendicular mean?
Right angle.
They make a right angle right there. So they can meet in a lot of different ways. I want them to meet exactly like that, like exactly opposite of parallel.
Reciprocal opposite.
Yeah, good. Say it again.
Reciprocal opposites.
Negative reciprocals. I like it. So perpendicular would be, if parallel is exactly the same, perpendicular is totally opposite.
There's a reciprocal or no?
Say again?
The reciprocal?
Negative reciprocal, yes. Because how many ways can you make something opposite? What's the opposite of 2? Or 1/2. The opposite of 2 additively is negative 2 because they cancel, don't they? But how do I cancel 2 out multiplicatively? 1/2. You with me?
Yeah, because
What happened? So the opposite of 2 additively is what I add to 2 to get back to the additive identity. Holy shit, what did I just say? Do you guys remember the additive identity is 0? Because why do we call it that? What do you add to something to keep it the same, to maintain its identity? 0. So 0 is the additive identity. So what do I have to add to something to make it come out to be 0? It's opposite. It's negative, right? Negative 2. What do I have to multiply something by to come out to be the multiplicative identity? What do I multiply by to keep something the same? 1. I multiply by 1 to keep something the same. So what do I do to 2 to make it become 1? The reciprocal. So those are both ideas of opposite. So if somebody just says, what's the opposite of 2? You have every right to say, you haven't asked me enough yet. What opposite? Which opposite do you mean? Do you mean additive opposite or multiplicative opposite? So this parallel is exactly the same. Perpendicular is totally opposite, meaning both opposites. So for example, if my slope is 3, what's the perpendicular slope? And that's the sign for perpendicular. Negative 1/3. Right? If my slope is 4/5, what's the perpendicular slope? Negative 5 over 4. Slow 4. So it's not too bad, right? You guys kind of with me?
Yeah.
Yes, sir.
What's the name of the line where there are infinite solutions? Like one line's in the same place as the other one.
Oh, so we're almost there. We're not quite there. That's the next section, actually. So we're going to start looking at lines and what the answer is for 2 separate lines. Is where they meet. And if they meet everywhere, that's a dependent system, yeah. So that's the next section. Okay, so here's one of students' classically favorite problems with lines. Find the equation. And I'm going to write equation like this. I almost just did it. See a little n? Just because I don't like to write a lot. Because I can't read my own. No, I can't. Find the equation of the line that does something. Well, for the equation of a line, what two things do I need? Slope. Good. I need a slope and a point, and if the point happens to be the y-intercept, kick ass. Right? Find the equation of the line that does something. I need a point, and I need the slope. Right? Once I get those two things, I just plug it in. So, find the equation of the line that is perpendicular to and goes through So which one of these two things requires no work? I've got it. Point. They told me to point directly. -1, -2, check. Now how do I find my slope?
Very good.
Yeah, I know my line is perpendicular to this. So if only I knew this guy's slope, I'd know how to find my slope because it's perpendicular. I just negative reciprocate it. So how do I find this guy's slope? Careful.
Solve for y.
Yeah, solve for y. Right? It will end up being 2/3, but you got to be careful. So if you solve this guy for y, how do you solve that for y? All right, subtract 2x. And then divide by -3, I like it. I only care about this guy's slope. Don't worry that you get this ugly -11/3. I don't care. All I need from this is its slope. His slope is 2/3, so what's my slope? -3/2. Sweet. Check. I'm going to let you absorb that for a second. Okay. So, now that we've got those things, which equation can I use directly? And I can use this one. I actually can use this one here too. So I'll show you that in a minute. This one I can use directly because it's got a place for the point. It's got a place for the slope. Right? So the minute you find these two things, you plug them in and work it out. So what I got? Y minus, good. The y piece equals the slope. Careful, -3/2. Because ours was perpendicular. X minus the x piece. Stop with it. Is that cool? So just plug it in. Here's my x1, y1. This is my one point that I got. Plug those in the right places. My slope I just figured out. Plug it in the right place. And then just clean this up a bit. So what do you get here? You and then you can subtract 2. Y equals -3/2 x minus, good, 7/2, because this would be 4/2, so it'll be 7/2.
You're going too quick.
These things happen. But this is plug and chug and then simplify. We should just be able to tear right into that. It should be something we just get into and just do it. Right? Not a big deal. The hard part, of course, is remembering how to get from this to this. Does that sound familiar? You guys remember problems like that? At all? Yeah? So, cool. Okay.
Is the answer 7 over 2? Is that a 7?
Oh yeah, so negative 3 halves minus times 2 to 4 halves. Yeah.
Oh, okay.
Real quick, if you wanted to use this one, it doesn't look like it can use this one, but I can. Y and x can be any point that's on the line, and I know a point on the line. Negative 2, negative 1, right? Or negative 1, negative 2. M is negative 3 halves, and now I can solve for b. So have you guys ever seen that?
Yeah.
A few of you guys. So you can use this equation because there's a place for everything, but this has a place for everything also. Just be careful at the end. The biggest mistake I see is people forget. Oops, got it. So you get the same thing there, don't I? For the b. Negative 3 halves minus 2. So again, negative 7 halves is b. And people stop there. But no, I asked for an equation, so now I say y equals negative 3 halves x plus b, which is minus 7 halves. Same thing we got over there. Thank God. So either way you want to do it is fine by me. Okay. All right. Yes, sir.
I'm just confused.
What's up?
I don't know. It says the m equals negative 3 over 2 over there, but right next to it says the slope's 2 over 3.
I love it. The slope of this line is 2 over 3. That ain't my line. My line is perpendicular to that line. So if this guy's slope is 2/3, my slope is negative 3 halves. Cool. I like it. If I would have said parallel to that line, then I would have used 2/3 directly. Okay. So this section is full of stuff because the last thing it has in it is actually the idea of functions. You remember f of x, g of x, h of x, c of x. All these of x. Domain and range. You guys are at the time of day where you're fried, like you just ride it out until it's time to go. It's funny. Everybody. All right, dude, come on, stop talking. But very quickly, no break. Take a break and we leave later. The idea of function. I don't remember if we talked about this or not, but anybody ever watched the movie Highlander?
Yes.
Yes, cool. What was the saying from Highlander?
There can only be one.
There can only be one. There could be only one, exactly. So, function is a special kind of relationship between variables. For every input, there could be only one output. Right? For every input, which is normally which variable? X. There can be only one. Y. Which normally is Y. It doesn't have to be. That would be a function. So if I said, is this collection a function? Is this collection of points, is it a function?
No.
Why not?
They have the
It
same.
has to.
Yeah, be very specific.
They have 2, 3.
Yeah, 3 goes to more than one thing. Does it matter that 5 goes to 2 and 1 goes to 2? No, that does not matter. So really, the reason we define functions is because they make physical sense. If I throw this marker, it can't get. Then if I throw the marker, then at some time it's going to be somewhere. It's going to be in one place. But if I threw the marker and said, okay, 2 seconds later, where is it? And you said it's here and it's there. Then it's like, what the hell just happened? So for every input, for every time that I ask you, there can be only one place that marker is at. Kind of with me? So the idea of function is not exactly just this, but it is tied to the idea of a physical situation. It has to have one thing happening at one time. You with me? So if I said, what size shoe are you wearing on your left foot? Because some of us have different size feet. But if I said your left foot, and you said size 10 and 11, do you have two freaking shoes under your foot? Right? There could be only one output to my question. You guys kind of with me? So that's one reason why we define something called a function. So this would not be a function. Not function because of this. 3 has more than one output. I like it. Or what if I wrote it like this? That looks weird. Somebody tell me one point that's represented up here. 27.2711. So the domain, the input is 1, the range is 4, the output is 4, so forth. So is this a function?
Yes.
Beautiful, because every input has only one output. I don't care that some share an output, right? You with me? Because if I said, how high is that book at 0 seconds? It's about 3 feet. How high is it at 5 seconds? 3 feet. Right? So it's okay for something to have the same output for different inputs. It's fine, right? It's not good for it to have, where's the book? There and over there. Right? So that's why I can't have more than one output for an input. They can have the same outputs. It doesn't matter. Yeah, we just work.
Great.
No? What's up?
Oh no, I was trying to work on the original part so I could get that down and missed what you said.
Shit. All right.
Going
So
too fast.
basically, every input can have only one output.
Okay.
It's sort of like me saying, what's your mom's name? Oh, yeah, how many moms do you have? You say, God, she's my mom and she's my mom. No, only one of them gave birth to you. It wasn't a joint effort, right? So you can only have one output to that question. Okay. So that's the idea there. And the quick way to do this is exactly like somebody said, if I see any repeated X's, I know it's not a function.
Okay.
If I see an arrow coming from 1 twice, if I see 2 arrows coming from something, that would not be a function, right?
So kind of like the 2 and 3 going to the 7.
That's fine. This is a function, no problem. Does any input go to more than one output? 1 only goes to 4. 2 only goes to 7. 3 only goes to 7.
Oh, so
That's
you're
a function.
So you're only worrying about the 3 being the same, or the X portion.
Yeah, so if I said domain range, if I said 1, 2, 3, 1 goes to 4 and 7, that is no good. Right? Person 1. How many TVs do you have in your house? 4 and 7, sometimes 7. Or sometimes no. How many do you have in there right now? You with me?
Got it.
1 works sometimes. No. Yeah.
Just so it's not necessarily about letters, it doesn't matter if the second number, because you might.
It doesn't matter if the second number repeats. So that was not a problem.
So no matter what.
Yeah, because at 1 second the book is 2 feet in the air.
Yes.
At 5 seconds the book is 2 feet in the air. That won't freak
If
me
you said
out.
function of y, it would still be the first numbers.
Say again, sorry?
Okay, so if you said like the function of y in that, it wouldn't matter.
So now, here's the thing about the letters we use.
Yeah.
We normally think of this as the x-axis and the y-axis.
Yeah.
This could be the time axis and the profit axis, right? In which case we hope we're doing this and not this. Got it with me?
Uh-huh.
Now, if I said a function of y, then technically I could think of this as the y-axis and the x-axis.
Okay, that's what I would do.
All right. But when you start, let's not go there right there. Because in that case, you have to be careful about which way matters, right? And we're not going to do anything where that flips and we don't flip the graph and all that kind of weirdness.
Yeah.
We're going to assume this is basically almost always x and that's y. Or time and something else. We're not going to say that's y, that's x now. Yeah. Not yet. That happens later. So what about this idea of domain and range?
Sure, I have a question.
Oh, yeah.
You know how you said if the x's repeat, then it's like a sign that it's not a function?
Yes.
Let's say if it was 3 and 4, 3 and 4, what would it matter?
Then that wouldn't really repeat. It's just somebody wrote that point twice. You know what I'm saying? Sort of like you can't take 3 people with you, only 2, and you say his name twice.
Oh.
You know, that's not more people. That's the same person twice. You with me?
Yeah.
Yeah. So if I would have said 3, 4, 3, 4, that would be really evil for me to do that.
Yeah.
Right.
So it's not a fraction.
I just wrote the same point twice. It should not have even wrote it the second time. Right. So if I ever did that and you got it wrong, I wouldn't take any points off because that was my mistake. Okay. Domain deals with inputs, which is normally X. Range deals with outputs, normally Y. So, visually, if I have a function that does something like this, all right, you guys with me?
Yeah.
Section 9.4.
Page 586.
This is still 9.3. Yeah, this is the last part. So 9.3 is like dense with stuff. So I had a function that looks like this. Real quick, first thing is the visual representation of this definition. The visual representation of this definition is, I don't know if you guys know, remember the test you have to do to see if it's a function. For every x, there can be only one y, so I look at a vertical line. If a vertical line goes through this more than once, so if I had this situation, that would mean this x goes to more than one y. So the visual is the vertical line test. Sound familiar? So if any vertical line goes through more than once, it does exactly not this, right? So then it's not a function.
But doesn't it correspond, given that, doesn't it still correspond to the alternate? Because the function is supposed to be corresponding to the alternate equation or the alternate representation. That's what a function is supposed to be doing.
A function is it's funny you use the word, a function is a correspondence between variables where this does not happen. So a function is a special subset of what I think you're talking about maybe. So this is still a relationship between x and y.
Yes.
As y changes, x changes, and so forth.
Yes.
But it doesn't do it in the way the function requires. Because it comes back on itself like that.
At the point
So
that-
functions are more specific. They say any vertical line can only go through once. Can't go through more than once. Cool? Because if it went through this, like I shoot a missile off, and then at this time the missile's here, here, and here. Well, what happened to my poor missile? Right?
Separate.
Yeah, something bad happened. Right? Okay. So on this one here, what would the domain be? So domain is the inputs I'm allowed to use. So what's the smallest input I'm allowed to use?
0.
-3. Because that's the smallest input that has an output. Does -4 have an output? No. So I can't use -4. It doesn't have an output. So I normally what I do is if I want domain, I walk a little dude on the x-axis. Here's my little dude. What's the first time he sees the graph when he's looking up and down? At -3. And what's the last time he sees it? 3. So the domain here would be -3 to 3. For the range, you have the little dude get up and go to the y-axis. Good. Well, here, I'm trying to make it. Did I almost get there? So the range is -2 to 4. Is that cool? Because that's he sees it here first. That's the lowest output that I get, and the highest output I get, and I don't skip anybody in the middle. So it's -2 to 4. Is that cool? It's very direct. Domain is x value. So you look at the x-axis for the domain. You look at the y-axis for the range. Maybe. Yes, sir.
So would you do the same thing if it's flipped or upside down forever or whatever, if you flip it or whatever?
You do exactly the same thing.
Or if it's like,
Yeah. No matter what this looks like,
you do the same thing?
you do the same thing. So if it looks like this,
Okay.
then the domain would be here to here, right? And the range would be, looks to be, look at tie almost here to there. Is that cool?
Okay.
That would be domain. That would be the range. You want to capture the lowest and highest inputs. That's domain. Lowest and highest outputs. That's the range. How we doing?
Wait.
Yes. So a little something related to that. Is that a function? Yes. In fact, I put an F there, the function. What's the domain of this function?
-2 and 6.
And? I like it. Now, I can't write interval notation here because does it include all, what are the only x values it has? Those 4. It doesn't include the ones in between. This is a line. It includes every single value across. You see? This is separate points. So my domain would be a listing of x values. What's my range? 7, 5, 1. Yeah, again, don't list 7 twice, right? Once you got it up there, you don't have to put it again. Cool. Is that cool? So there's a 2, yeah.
If you connected all the points, then it would be
Then it would
-2, 6, and
interval notation
7, 1.
possibly, yeah. Depends on how I connect them,
Right.
Like how far up I go.
Oh yeah, if you like connect them.
Yeah, cool. Okay. Okay, cool. Man, 9.3's got a lot in it. Let's see, 9.4, and then we'll see what time it is here. Probably let you guys out early, because I'm still packing for moving. Oh, it's going great.
All right.
Huh?
What area?
I'm moving. I hate that I have to move, but I just have to today because I live right off. I walked in my street and I can see the harbor. Right, so July 4th. So I live right in between Little Italy and Old Town, basically, Mission Italy. But I'm moving to South Park, which is interesting. Huh? Just things happen. Where am I? Oh. What's that?
There's a lot of stuff to do, like in North Park, you find it.
Yeah, I used to live in North Park. And there's a lot of stuff to do. A lot of stuff to do.
Hmm?
Hmm?
You ever been to Hamilton to North Park?
No, I don't think so. I don't know. Is it good? I missed it. All right. Okay. Where was I? Oh. 9.4, yeah. So 9.4 is systems of equations. Now let me just throw a few words at you guys. Substitution method. Okay, good. I'll even accept the because that means you know what it is. Elimination method. I don't know if they call it that. Addition method. Do they call it that?
Yeah.
Remember this stuff? So this is systems of equations and how to solve them. Yes, ma'am.
Is matrix in there too or not?
Not yet, but we will be talking about matrices
Okay.
later. Right now, we're just doing basic systems of 2 equations.
Okay.
So the idea is this. So here's the idea behind everything.
So don't you just...
How many answers does that have by itself? Careful.
2. No.
A little bit more.
No, infinite.
Infinite number of answers. So my little bit was just a little bit off. Because for every value of x you can imagine, and then all the other ones you can't, you have a value of y that comes out, right? So there's an infinite number of points. And really, that's one reason why we graph things. Because if I said, give me all the answers to this, how long would it take you? Forever, and then your kids would continue to work, and their kids would continue to work. That would really be weird. But if I just graph it, then I say, there's all your answers, I'm done. And how much work does it take to graph that? Not much at all, right? So if I connect the points that I find, I say, okay, everywhere I'm drawing this line is an answer. So there are all your answers. So a graph of this equation is a visual representation of all of its answers. So if I graph this and it represents all of its answers, and I graph this and that line represents all of this guy's answers, what's the answer to the system? Where are they both true at the same time? Where those lines cross. Now, do two lines always have to cross?
No.
Because they could be parallel. Shit. In which case you'd have how many answers? No solution there, right? They don't cross at all. So if the answer is where they cross and they don't, no solution. So this is somebody who was asking this earlier. Yes. So if they cross everywhere, if they're actually the same line, then it's an infinite number of answers, right? So really, another way to look at this is, I have two things I don't know. So how much information do I need to fill in what I don't know? I need two pieces of information.
So substitute the y on the bottom.
Almost, not there yet. If I graph this one, what's this? What's the y-intercept? -1. And what's the slope?
3 over 1.
So up 3 over 1. Up 3 over 1. Up there, okay. And what about this guy? Oh shit. What's the y-intercept? That's me not thinking that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sure. And the slope is? Yeah, down 2 over 1. Down 2 over 1. So then the answer would be that. It's 2, 5. And to be completely honest, that's how I made these. I let x be 2, so then I saw y was 5. So then when I wrote this, negative twice 2 is -4 plus 9. That's why I put a 9 there. That makes it 5. Right? You guys kind of agree so far? So any method you use to solve this is actually has this in its background. Every time you find an answer to a system of equations, that's the point where those would meet. Okay, cool. So now accept other ways to do this. What's another way to do this?
Multiply by 2 on the top and then negative 3 at the bottom.
Okay, so
What was that, the elimination method?
yeah, that's elimination.
Okay.
So if I want to use the elimination method, there's actually a much more direct way to do it. If I just multiply this one by -1, then the y's would go away, right? So I let 1 be y equals 3x minus 1. I'm going to multiply 2 by -1. And what do I get? I like it. I just took the second one and multiplied it through by -1. That's all I did. Now, why the hell did I do that?
So you can eliminate it.
Because now when I add these together. Now, why am I allowed to add freaking equations together?
Because they're like
They're opposite.
So, I could add these together right now if I wanted to. I don't want to. Why am I allowed to? Well, what am I adding to this side? I'm adding -y to this side, right? You with me? -y plus y is 0. I have to add the same thing to this side.
Yeah.
But what is -y? It's this. So if I add this to this side and that to this side, I'm adding the same thing to both sides. So part of you should be concerned. Why am I allowed to add freaking equations to each other? You actually are exactly following the rules. Whatever you add to one side, you add to the other side. Kind of with me? You guys are like, I was not concerned about that at all. Alright, that's fine. What do you hear?
5.
Add 10, divide by 5, x is 2. 2. Right, we got x is 2 earlier. And then you plug it back in to either one. Y is 6 minus 1, 5. So you can always answer it as a point. Yes, sir.
Looking at all this, what is the difference between this and solving for array?
Solving for a
Array? What's the difference? Like a line and an array.
array has a definite starting point.
That's it.
A line goes forever in both directions. Yeah. Okay. Substitution method.
So with the elimination method, are we subtracting or just adding?
We're adding. So what I always do is I make sure that the two things are opposite sides. So then I add. What about substitution method? if y is this,
Plug that in.
then I can replace that y with what it is, right? I use this information in here. So I can rewrite number 2 as 3x minus 1 equals negative 2x plus 9. Is that cool?
Yeah.
Because I know from the first one, y is this. So when I write that, I'm like, why would I write y again? I can write what the hell it is. And now it's cool because there's only one variable in there. The problem with both of these is there's 2 freaking variables. So one way to handle it is you kill one of them. Die. Right? That's the elimination method. The other way is to be a little more subversive and you just replace one. Right? So now there's only one variable in there. And if you add 2x and you add 1, you get 5x equals 10. That looks very familiar. X is 2, you get y is 5, you get the same answer. Right? So no matter what method you use, you have to get the same answer, yes.
So with the, I'm still on the elimination part. So once you get your 2, x equals 2, do you put it in the original elimination solution?
Either one of these.
Either
one of these. Yeah. Either one of these equations you put it in, it's got to be the same because they're supposed to meet there. Yeah. So there's actually a way to check your work is to put it in both and make sure you get the same answer.
Oh, so you only have to put it in one then?
You only have to put it in one.
Y?
If you put it in 2, you're just kind of checking yourself.
Okay.
Good. This is the one place that they both have the same output. So I only have to put it in 1 if I feel really confident about it. Yes, ma'am.
For the elimination method, you said adding.
Yes.
Okay, let's say if there was like, say if the y, both of the y's were negative, could you add? So that the y's cancel out?
-2, I know.
So if I add this right now, I get 5x minus 2y equals 3. That's not good. I don't kill anything.
Yeah.
They have to have different signs.
Plus y.
Now I could subtract them, but then it's really easy to make a negative mistake because you're subtracting things that might have negatives on them and trying to keep it all in your head. So the very first thing I would do,
Add y to the other side and then
if I have to use elimination method, multiply one of them by -1, because then that'll make these opposite signs. Or I could, if I wanted to kill the x, I could multiply this by -4 all the way through, because then that would die. Right?
Okay, you said add over there, and we're adding over here too.
Hell yes, eventually, but not the way it is. Not the way it is, because the way it is sucks. What if I can leave one alone, and I can change the second one. Make sure it's the opposite sign by multiplying by -1.
But if you were to subtract the y's, would cancel out?
Second? Yes, you can subtract. You can subtract, but what I'm suggesting to you is if you're subtracting stuff where the sign is sometimes negative, so you got a minus and negative, and you try to keep that in your head, it's really easy to make a mistake.
Oh, okay.
If you just make sure the signs are different for what you're trying to cancel, then you're adding, and it's much less likely to make a mistake. Cool. So you certainly could subtract. Not the best idea, right? Because it's really easy to make a mistake that way. So now if I put these together, I get 3x equals 3. X is 1. Put a 1 in there, I get y is 1.
Yeah.
Cool. That's my go-to point to use as an answer if I'm worried about my ability to put an equation together. Okay. I think I probably feel a little bit like you do. I think that's plenty. So today we got through 9, 3, 9, 4. Don't forget quiz on Monday, and then we'll be getting into chapter 10.